Thanks for tuning in at Brackeys.
Hello everyone and welcome to this Unity 5 primer. This video is not going to be part of any particular series, but instead aims to give you insight into the new features introduced with Unity 5 and how to use them. So I've tried to pick out some of the most important and the largest changes, and you should see them on screen now. This video is probably going to be pretty long and you might know some of it already, so just click on the subjects that you want to learn more about if you want to skip ahead, or you can of course just watch the video the whole way through. So click on something now and we're going to continue. Cool. So the first thing we are going to be taking a look at today is the rendering pipeline. Quite a few things has changed in rendering. Most importantly, the lighting. So if we open up Unity, double click on Unity 5 once you've downloaded it, you can see that we have this new open dialog where we have access to tutorials, documentation, and the projects that we are working on. Let's just hit new project under this and let's call this Unity 5 primer. And we're going to put it on the desktop, I am at least. And we're going to set the defaults up for 3D. You can, of course, do 2D, but most of the changes to the rendering pipeline is on the 3D. If you want to know more about the 2D things that has changed, please go ahead and see the newest addition to the 2D platformer course, because there I talk about how to update to Unity 5 and kind of what that means for our project. You can also import some asset packages here. I'm not going to do that. Cool, let's hit create project and it's going to very quickly open up this project. Notice just how fast that is now. I've been using the asset store, so let's just browse away from that. And everything pretty much looks the way it used to when it comes to the layout. But you will notice that inside of the scene view, we now have a new default skybox, which looks very awesome. If you ask me at least. So the first thing we're going to be looking at here is just setting up a basic scene where we can play around with some of the new rendering features. So let's hit right click, let's go into 3D object and create a cube, which we are just going to reset and make 20 by 1 by 20 to kind of get us a ground here, and we're going to just rename this ground. Then we can make another object, right click, 3D object sphere. Let's again reset this, move it up just a bit. Let's call this ball. And yeah, I think it looks pretty good like this. You will notice that right now that everything is very blown out because these two are completely white. So let's just go ahead and make these some materials where we can then change the color. So let's go to project, right click, go under material. And let's make a ground material and also right click material and make a ball material. And I'm just going to change the albedo on the ball here to be a bit darker and then drag that onto the ball. And then the ground, we can maybe make that a color. So let's just make it a bit red here. Cool. So now that we have this set up, some things could become very apparent. First of all, we have this nice looking shader on the ball with some nice glossiness and this metallic feel. And you can also see that we have some reflection from the skybox onto our ground. So what is going on here? Well, with Unity 5, a lot of stuff has changed about the way that we render images. So first off, there has been introduced a whole new lighting system. It's called Enlighten, and basically it allows for things like global illumination, which means that we can have lighting bounce around the scene so that lighting isn't just direct, but we also get this indirect lighting that happens when a light bounces off objects, and that can be colored depending on the properties of the object. So that makes everything look much more interesting. We also have a bunch of new stuff to the shaders here. I'm going to talk about that in a second. And then we also have the ability to get lighting from our skyboxes and stuff like that. So I'm going to get into everything. But first thing that I want you to notice is that we have a soft shadow here. And this is different because also make sure that you are in, you have selected lighting up here, just to make sure that that's okay. But that's different from the normal Unity free version because soft shadows used to be a pro feature. What has happened with Unity 5 is basically all the stuff that used to be pro and the stuff that used to be free are now all free. That means that what was before Unity Pro is now called Unity Personal Edition. And then we have some extra stuff that now costs. So everything that concerns the engine, such as soft shadows or whatever, or image effects and all that, is available to us as long as we don't make a huge amount of money each year. Everything except the dark theme. So if you're very, very fond of the dark theme, you will still have to purchase that. But stuff like cloud building, the team license, and these extra features, and still also building to certain platforms, does still cost money. And this is a really great way to do it because it allows us to create very, very powerful full software using this free editor. Cool. So that means that free soft shadows are free. You can see that they are also selected by default. And what we can also do is we can go ahead and right click, go under light, point light, and you will notice here, if I just drag this up and go into shadows and select soft shadows, that soft shadows will indeed also work with point lights. So that's super, super cool. Cool. So let's just delete that light there. Actually, let's have it there. I changed my mind. So let's go into 3D object. No, light. I'm just going to Control Z this. That's easier. Cool. Just so we have some more three-dimensional lighting, so it doesn't come from just one place. That looks pretty cool. And what I want to dig into now, please select this as static and also the directional light as static. That will allow us to do some more effects. So what I want to do now that I've talked about shadows is talk a bit about the new shaders. So Unity's shader system has been pretty much redone from scratch. It's introduced a whole new kind of shader called a physically based shader, or PBR for physically based rendering. And what a PBS, a physically based shader, does is that it describes the property of our object. It describes it using terms that we use in real life, such as how metallic something is, or how shiny, or whatever. And then it emulates that inside of our scene. And what this allows us to do is, first off, it's very easy to create and describe the way that you want your object to look. But also you don't have to kind of fake the look of every object. Because what we did before was we wrote a bunch of custom shaders, or at least if you were able to, or found some on the internet, and you customized them and tweaked them and they looked really good in the scene. But as soon as you put them into another lighting condition, everything started looking bad again. The cool thing about physically based rendering is that we describe the properties of the object, and so no matter where we place it, it's going to look absolutely beautiful. So that's the really cool thing. And to show you this, I want to quickly download some textures. So let's head into the Unity Asset Store. I'm just going to log in here. So I'm just going to pause the recording for a second and I'll be right back. I'm back now and I've logged in. And what I want to do is just find some textures and materials. So we're going to go under the textures and materials tab there. And I found some pretty cool looking ones. If we go ahead and sort by price, we only want the free ones. I'm just going to see if I can find them here. I did find some nice ones. We might need to go into my browsing history. So let's do that. Let's go in here and let's search for ground. We have the ground textures pack. So you can just search for that, hit download on that. And the outdoor ground textures, you can also download that. I'm just going to go with the outdoor ground textures, I think. If we go in here, we can see that they are with normal, specular, and height maps for general use, and that's going to be really cool. We want something other than just the diffuse map. So let's import those. And I also found another package as soon as it's done importing here that you might want to check out. And that was, let's see if I can remember this. 1 second, I'll just check what it was. Okay, so I'm back and I found it. It was the tileable cobblestone texture. So let's just import that one also. So now that we have these imported, you can of course import whatever you want to. I'm just going to use these for demonstrational purposes. So, and now that we have these imported, let's start out by making ourselves a ground. So let's change this back to white. Excuse me. Let's go under the ADG textures, go under ground volume 1. And under ground 1, we're going to find a diffuse map, which we can drag into the little square here. This albedo here is what we call the diffuse. And we are going to change from the shader up here from standard to standard specular because we have a specular map. And the standard shader here, I haven't explained. This is basically where we do 99% of our material work. This is going to do so much for us. As you can see, it has room for specular maps, normal maps, height maps, emission, and detail maps, and secondary maps, and all that. It has so much very nice functionality. And the great thing about it is that if you don't use some of these parameters, it's not going to actually compile the code. So it's not going to be any slower if you use this and don't use all of the properties than if you were using a highly optimized or shader that didn't do as much. This is very, very optimized, and it works really great. So the albedo is what we usually call the diffuse. Then the specular, we're going to drag in our specular map. And as you can see, what this does, it basically prevents the whole surface from being this reflective specular thing, and only makes the important parts, which are basically the rocks here, actually have some specular value. And if we select the ground again here, we can then drag in the normal map. This is a standard normal map, and you can see just how huge an effect this can have. I'm just gonna maybe bump this down a bit to something like 0.4. It's going to be plenty, I think. I don't want to overdo it with the normal map. This is already quite a lot. And then we have a height map, and it's not too apparent on this one, so I'm not going to talk about it yet, but I will talk about it when we do the ball. It's very much clearer there. So that is just a quick overview on how to set up a basic material in using the new physically based shader, a standard shader. Then let's set up the ball here. Let's again change the albedo to white. Let's go into Cobblestone, and we can drag in the Cobblestone specular. Whoops. Under the map there. Let's change the tiling of this to maybe 3 by 3. Oops, not down there. 3 by 3. Something like that. That looks pretty good. And we're again gonna change this from, actually let's remain at standard here. Then we're gonna drag in the normal map, and we're gonna drag in our displacement map under height map. And you can see that it already sets up a very nice looking material. What we can do is we can change just how metallic we want this object to be. So if you want this to be completely metal, you can see what this actually does. Now it looks like a metallic surface, but this rock here is very much not metallic, and so we want this to be pretty low. In fact, I want it to be 0. And the smoothness here is kind of the smoothness of the specular, and kind of the reflection on from the outside. And I want this to be fairly smooth, but I still want to see some detail. So maybe 0.4, pretty close to the default, is going to be pretty good for this texture. You can maybe make it even more faded, but I still want to have some nice details and wrinkles there. I think that looks pretty nice. Cool. Now it almost looks wet. We might want to make it a bit more smooth. or set the smoothness a bit lower, I should say. Cool. And here, let's try and adjust the height map slider to see what this does. So we can bump it up, and you can see that it extrudes certain parts of the image. And we can bump it down, and you can see that it goes back to flat. So that's basically what the height map does. And the displacement map here is not genius. I think it could be a whole lot better, but you get an understanding of what it actually does. Oops, that was for the ground. We're going to go back to the ball here and just give it a bit of height. Maybe 0.3 is going to be fine. So you can see these displacements up here, which is really makes the material look more realistic when you view it from the side. Cool. So that was an overview of the physically based rendering shader. This video is going to be so long. I've already talked a bit about global illumination. I'm just going to show you what this does under the light settings, and we're going to look at emission also. So if I go in here and create some new objects, first off, I want to mark the ball and ground here as static. And you can see down here that it starts doing some rendering, and that's because on static objects, it's going to calculate some nicer looking lighting. So everything that is going to be static, please mark it as static. So now go into 3D object, and let's make a cube here. Let's drag this guy up here, and I'm just going to duplicate him and move him over. And on the left one of these, I want to make a new material. Let's make a new material. Whoops. Right click, create material. Let's call this red. Drag it onto the left guy. Let's change this color to red. Now go on, select both cubes and mark them as static, and you will see something magical happen as soon as it's baked here. You can see that we have spill light. So we have light that bounces from our two light sources onto the red surface, and then the bounce light that returns from the red surface is now colored both from the source of the light and depending on the properties of the material here, which is of course very red, and it's going to spill onto the object over here. So that's really cool. That's called bounce light or spill light. So now that we have that set up, I'm just going to show you how you can adjust some lighting settings under the lighting panel. So I have mine over here. You can find it under Window, Lighting. Cool. I like to dock it by the inspector panel. What we can do here is we can first off adjust our skybox, this one up here. We can then say what we want our ambient lighting source to be. Before, ambient light was pretty much could pretty much only be a one single color, one single color here, and it really didn't look too good. Now the light will depend on the color of the light, and the intensity of the light will be colored depending on the skybox, so the direction of the light will actually matter. And you can see what this scene would look like if we completely turn off the ambient light. So let's drag down the ambient intensity here, and you can see that now we have no ambient light. And if we disabled our point and directional light in here, and it bakes, you can see that we almost can't see anything. We still can see a little bit. And the reason why is under lighting, we also have reflection intensity. So if we pump that down, everything gets black. But the reflection intensity here is really, really cool. It allows us to adjust on a global level how much reflection we should see from the skybox, and then also from reflection probes, which I'm not going to go into, but that allows you to create reflection depending on not only the skybox, but the actual objects in scene. So that's super cool, and you can of course adjust the bounces and play around with all that. So I'm just going to bump up the ambient and intensity too, and turn back on the lights. So we have this cool looking scene again. And you can see here what the reflection intensity does to our scene here. I actually think it's a bit too high by default, at least for our scene here. We can go into our each object here and manipulate it but I think we should just do it on a global level. So I'm just gonna bump down the reflection intensity a bit there. This looks a bit better. Cool. You also have a bunch of other settings. I'm not going to go too much into them, but we can boost the indirect lighting. That's going to happen, and you can see what that does. That's a cool slider to have. We also have the bounce boost, the bounce lighting I was talking about, when something hits and then bounces off. And I could go on forever. Just wanted to show you kind of that does. Then we're going to look at emission. So if we take and duplicate this object one more time, and notice that it's marked as static, and we can just scale this up a bit maybe, and then scale it down, scale it up on this axis, so we have this nice flat surface that we can maybe turn over a bit. This process is going to be very known to you if you ever used Blender's lighting system called Cycles. And this allows us to create light emitting from a surface. So let's make a new material for this. Create material, and let's call this emission. Let's drag it on the plane, and let's just leave the albedo and the metallicness and all that. We're going to go under emission and set this to 1. Notice you can both get this from a texture or from just a single color. Actually, let's set this to 5 to make it more apparent. And we can maybe change the light here to a greenish color, or red, or whatever you want to do. So let's do a Brackeys purple here without it being too girly. And let's just bump this down again to maybe something like 3. So you can see what that does. And that's actually a really, really cool feature. Awesome. So now that we have that in place, I just quickly want to show you also that if we take our ball here, move it over, create a new material for this called reflection, and drag it onto the ball. What we can do is we can bump up the metallicness, and you can see just how reflective these materials can be. And if we even tidy up the smoothness here, you can get these really cool looking glossy surfaces, which will of course also be affected by a height map or a normal map. So you can get these really cool looking wrinkled metallic surfaces. Just a cool tip for you. Awesome. So that pretty much concludes the whole lighting part of our rendering essentials, so to say. The last part is just that we now have image effects available. This was before a pro feature. So if we maybe go under our game view here and adjust it so it looks a bit better. So let's find our camera. Oops. For some reason, my Unity froze there for a sec. Okay, it's back. So if we move up this camera, actually, I think there's a feature called center camera on view. Move to view here, Control-Alt-Shift, and then align with view, Control-Shift-F. There we go. So now our camera will be aligned, and if we bring up our game view, for some reason that closed, there we go. You can see that our camera sees what we see. Then we can go under Edit, Project Settings, Quality, and make sure this is set to Fantastic. Indeed it is. And then at last, we can import a package called Effects. Image effects are also under Effects. There are a bunch of things under Effects, and it's just gonna process these. So just wait for that. I think it's actually pretty annoying that it isn't just called image effects. I don't think the new names are that descriptive of the content. For example, if you just look over it, it's hard to say where you would find, for example, some skyboxes. It's not under environment, for example. So, but it's just going to import these, and hopefully we can get done with this so we can move on to the next segment. You can see it makes an editor folder and some standard assets under effects here. So that's really cool. And what we can do is we can select our main camera, hit add component, and we now have image effects. And we can maybe go under bloom and glow, select the bloom here. So you can see we now have that effect available. That's really a favorite. Then we can maybe select some camera depth of field maybe. So we can get that going too. And this is going to look really weird. And you have all of these available. We could also go into color adjustments, maybe making a color correction or whatever. We can do a vignette also, which is probably under camera here. So we can bump that up. We have all of these cool things to play around with. So this looks pretty artistic. So that's actually kind of fun, and you get the idea. Awesome. So that concludes the first segment, and let's go ahead and jump on to the next one, which is going to be the audio mixer. Okay, so welcome to the audio segment. This is where we dig right into the audio mixer that is now introduced with Unity 5. And actually probably the largest workflow change that we see with this new update is how we go about doing audio in our game. So that's really, really awesome, and I have so much to show you. So let's just get right into it. You can see I've set up this test scene just using the same techniques that I showed you in the rendering parts. And it has this ball, which I've called the speaker. This represents an audio source that is in our scene of some sorts. And then we have a ground. And what I want to do, if you haven't done this already, is right click down here, go under import package, and import all of the characters. I've just done that already, so you don't have to wait. And this way we can drag in a first-person controller, which you see here under first-person character, under characters, first-person character, prefabs, and then FPS controller. And let's just drag that in there. The cool thing about this guy, if we just reset the transform and drag him up a bit here to make him stand on our surface, maybe pull him back a bit too, is that he will have some audio on him already with footsteps and jumping and landing. And we'll also be able to move around so we can see how that affects the sound. So if we hit play now, as you can hear, we now have footsteps, and we'll be able to hear this when we jump and land. So that's really cool. And I've also gone ahead and imported two free packages from the Unity Asset Store. And they're both under audio. The one is free game music, and the other one is the ambient sample pack. So we're just going to be using some sample audio. Both of them are free, and you can of course use any audio you would like. So what we are going to do is, first off, we are going to right click up here. We're going to go under audio and select audio source. We already have an audio listener, which is the other part of any kind of audio setup. On the FPS controller, we should have an audio listener. It should be here somewhere. Maybe under the first person character, there we have it on with the camera. We have an audio listener. So just make sure you have one and only one of those. And now we also have an audio source. And in the source, we're going to drag in some ambient sound. And this is a rain loop on 29 seconds. We're going to drag that into the audio clip. This looks pretty familiar, except we have a bunch of new settings down here. And then we're going to make sure it plays on awake and that it will loop. The priority you can just leave as B, and the volume we're going to adjust another way. Just make sure that the spatial blend, and yes, you can now blend between 2D and 3D simulation, so that's really awesome, is pushed all the way over to 2D. Excuse me. Cool. So what will happen now if we just rename this to ambient sound and we hit play? We can hear some rain. So that's really cool. And this will stay with us no matter where we walk. So our direction and our placement in 3D won't affect this at all. What I also want to do is I want to, on the speaker here, place a audio source component. So simply type in source and hit enter. You can see that it places a source right here. And what I want to do here is I want to drag in some music to this. So this With Love from Vertex Studio 4, that's what I'm going to drag under here. Make sure it plays on awake, make sure it loops, and now drag the spatial blend all the way to the right. So now when we hit play, we can hear footsteps, we can hear rain, and when we get closer to this, we should also be able to hear some music. So that will depend on where we face. So you should be able to hear this go from one monitor to the other. If you don't, then that's fine. Then the stereo audio hasn't gone over to whatever device you're watching on. But the main thing is that it is indeed stereo sound here, and it emulates 3D space. But that is not really new. The new part comes now with the audio mixer. Ta-da! This is a really, really awesome feature. It's something that I've been missing in Unity for so long, and I've tried a bunch of different plugins and all that to make it work, but nothing has been quite satisfactory as to the level that this new mixer is. So if you go under Window, you can select Audio Mixer. It's also under Control 8. And we're simply going to go ahead and hit the plus sign here to create a new mixer. And we're just going to call this one Main Mixer. Excuse me there. And you can see that we have a bunch of settings appear. First off, most importantly, we have the groups. And basically the groups allows us to split a bunch of different sounds into some different groups here, or buses maybe, and what we can do with those is we can control their we can control their volume, we can control whether they're solo or muted, and we can give them a bunch of effects. So to demonstrate this, let's make 3 new groups. First off, we're going to make one for music. We are also going to make one for we don't want that to be inside of music, we want it to be inside of master. You can nest these groups, which is really cool. Then we want one for, let's do player, with footsteps and all that. And we also want one called ambience. So you can see we now have 3 sliders and the master slider, each representing a volume. And if we just go ahead and hit play right now, you will notice that the audio plays, just like before, but we don't get any response in here. And the reason why is we need to assign the different audio sources to these groups. So if we go into, let's say, first off, a speaker, find the audio source, you can see it has an output, and we need to here give it a mixer group that it should output to. So this idea of routing different sources to different channels is really, really important. So you can either go in here and select something, or you can drag from the project down here. You can say the cool mixer setup we have here, or you can even drag it from the mixer. That's up to you. I'm just going to drag from the mixer here. So drag the music into there. Oh my God, it keeps going. I'm sorry. Cool. So now that we have the mixer or the music main mixer group selected there, let's also select our FPS controller, find our audio source, and everything is under one audio source here. And we're simply going to drag in the player there, and then find our ambient sound and drag in ambience there. So you can, of course, have multiple audio sources assigned to each group. That's kind of the point. But this is just a demonstration, so I don't want to go into that. So what we can do now is we can hit play, and we will see the different mixers actually showing the current volume in decibels that is going through the mixer channel. And this is super awesome. And if we dog it down here by the console, move this up, go into game view, you can see that the player will also react when we do some footsteps. And the cool thing about this is that we can, while we are playing, edit these settings. So to show you this, simply click edit in play mode, and this will allow you to edit. You have to click this or you cannot actually change anything. And the reason why this button is here is because changes to the audio mixer will carry over from play mode. Normally when you make a change, it just disappears as soon as you stop playing. This is really great for testing, but it's annoying if you want to tweak things while the game is running, which is very important for audio. That's why we have this button. So simply click edit in play mode, and now we can, for example, adjust the volume. So we can maybe make the ambience a bit louder. Drag down some of the player footsteps. I think they're just a bit too much. And we'll just leave the music be, I think. So this way we can really adjust our mix, and I mean we can go all kinds of crazy here. You don't have to be as limited as I am here in my options. So we can just maybe drag down the music a tiny bit there. Cool. So other than adjusting music, we also have the ability to add effects, and this is where it gets really cool. So a good example of this is actually with this music here. I have this red ball set up to be a speaker, but sound coming from a speaker isn't just natural, clear sound. Often if it's a mid to low end speaker, there will be some distortion. It will maybe change the sound spectrum, the frequencies a bit, maybe to make them sound better, or if it's a bad speaker, it will make them sound worse. And so we can go in and add some effects to this to make it sound like there's a speaker in game. So let's move a bit closer to the ball here, so we can really hear the music. And I just quickly want to add some effects to this. So I'm gonna drag back the audio mix up here, so we can go away from game mode and into the audio mix instead. Drag down the console here, and let's add some effects. So let's select the music. Let's go on, to the right here, called where it says add effect, or you can click add here. The effects will appear down here, just like any DAW or digital audio workstation that you might have used in the past, if any. If you have, then all this will be very familiar. You have the mute button, which of course mutes, the solo button, which solos the track, and then you have this B. This is for bypass, and that basically turns off all the effects on your channel, which basically allows you to quickly listen with and without effects and compare. So if we click add effect here now, we can go under and we can add some different effects. First off, I want to do a param EQ. This allows us to change the frequencies, the frequency spectrum. You can hear that I can turn off all of the high frequencies, so it gets really dark, or we can turn off the low frequencies, or we can boost a certain part of the spectrum. For example, if we just wait for the music to come back here, we can boost the lows, boost the highs, boost the mids, so you can really hear what that does. So in my case here, I want to kind of maybe boost the middle channel, and then we can add another effect. And for this I want to do a low pass, so we cut off some of the high range here. I want some resonance, so this will really distort the music, and you can play around with the cutoff frequency. That sounds pretty good, I think. That will turn off all of the clarity in the sound, and then maybe a bit of distortion. Please note that distortion will make your music quite a lot louder, so you want to bump down the volume and then bump up the distortion. Something like this actually sounds pretty good, and you can listen with and without the effects. So you can hear it's much louder, but it's also distorted. And we're just gonna bump that down a bit. Actually, when we are this close, we want it to really fill out the space. Yeah, I think that actually sounds really, really nice. And why don't we go ahead and just have a listen from the beginning here. So if we go into game mode, I'm gonna stop talking and just play around this. Cool, so now that actually sounds like a speaker in our game. One quick thing I want to mention about the audio mixer, now that we've been over sources, groups and effects, is snapshots. We're not going to go into views. Snapshots are basically presets of settings. So if you've made a configuration like I have here, it's a good idea to store it in a snapshot, and then you can quickly shift between different configurations. For example, if we hit play here, we go into the audio mixer, whoops. We go into the audio mixer, hit edit in play mode, create a snapshot, call this maybe no music. Then we can turn off the music here and maybe bump up the ambience instead and the player sound. And now you can hear that when I switch between these, they will animate. So that's a very quick and easy way to animate a bunch of parameters very easily. So you don't have to go in through code and just change all of them at the same time. Awesome, and you can of course set one of them as default by right-clicking and hitting set as start snapshot. So that will do. Awesome, so that was basically the audio walkthrough. Now we're going to continue on to the next segment. So now we're going to have a look at scripting, what has been changed in terms of programming in Unity. So first of all, I quickly want to open up Unity here, of course, and show you a scene I've set up. So this is very basic. It's just using the technique showed under the render segment, where I have this ground, I have a light, I have a ball with a red material on it, and I've added a rigid body which is currently using gravity to that. Make sure it's not marked as static because this is going to be moving. And I also have an FPS controller standing on the ground. This is from the standard asset. So if you right click, go under import package, characters, then it will be under the characters, first person character, and then prefabs, there is the FPS controller, just to get you caught up. So now when we hit play, you'll notice that we have a ball here that we can push around, and we can also jump and look around ourselves. Cool. So what we want to do now is have a quick look at what has changed in terms of scripting. And really there are so many changes to the Unity API, and there are so many additions, there are a bunch of cleanups, a lot of code is going to run much more efficiently now. And really one thing that has been improved quite a lot is how quickly we can instantiate objects. And that's very awesome. So I'm going to show you a case where we are going to instantiate a bunch of objects and just show you how fast that is now. I'm also going to show you the new physics system, how easy it handles a bunch of objects at the same time. It's now been upgraded to PhysX 3.0, I believe. And it's definitely gotten a huge update, which makes it much easier to have these huge amount of objects or rigid bodies in a scene. So we are going to combine those two instances, and then I'm also going to show you the changes with these easy component accesses. So to do this, I'm going to create a script right now that is going to spawn a bunch of balls on a line that are then going to fall. So in order to do this, I've made this ball into a prefab by dragging it to the project panel. And now I want to make an empty game object. So Control Shift N or Command Shift N if you're on a Mac. And I'm just going to call this underscore spawner. It really doesn't matter what it's called. And I'm going to reset the transform and then move it up to where we want the balls to start spawning upwards. And then go under Add Component, New Script, and we're going to call this one Spawner. Then let's double click it to open it up in Mono Develop. And it's just going to take a moment. Cool. I'm just going to zoom a bit in on the code here, and everything looks pretty much like it used to. I'm going to delete the start method and instead make two variables. The first one is going to be a reference to our ball. So that's going to be of type. That's actually going to be a public. So we're going to do public transform. And we're going to call it ball. Then we're also going to have a private. And this is just going to be a boolean called do once. That will make sure that we only spawn all of these balls once and not each frame. We're simply going to use the update function method to check whether or not we are going to spawn. So in here, we're going to say if time, which is the amount of seconds that has elapsed since we started playing. If that is bigger than 3, so if 3 seconds has gone by, I want the balls to start spawning. And in order to spawn a huge amount of objects, we are going to be using a for statement. So for int I equals 0, when I is less than, and then maybe 100, we can maybe make this into a int variable here up here. So we might say amount, spawn amount. So if I is less than amount, then we're going to default this to 100. Then we want to increment I. Whoops. And then inside of this for statement, we want to instantiate. And what we want to instantiate is the ball. And the position is going to be, for now, transform.position. And simply using quaternion.identity, so it doesn't have any rotation whatsoever. And then down here, we want to set doOnce equal to false, because we are going to be defaulting this to true. And then here we want to check if it's true. So if time is greater than 3 and doOnce is true. So that's the setup that will make sure that when the 3-second mark has passed, it's going to spawn 100 balls, and then it's going to make sure that it doesn't do it next frame also. But currently they all spawn in the same position. I want them to do this kind of just this huge row of objects. So we're going to create a way for us to change the position depending on the increment. So in order to do this, let's create a temporary variable. This is going to be of type vector3. This is going to be called pos for position. And we're going to make this equal to a new vector3. Vector3 being a variable that stores 3 numbers. In here, we're going to type transform.position.x. I simply wanted to have the x position of our spawner. Then it's going to be transform.position.y and then plus I. So as I gets bigger, as we spawn more balls, it's going to set the position higher. So it's going to start from the button and then just spawn upwards. You can, of course, do I times 2 if you want a bigger space between them. I'm pretty sure that my ball here has a 1, 1, 1 scale, so this is just going to put them as close as they can be. And then transform.position.z, because we want to emulate that or duplicate that from the spawner itself. So now we can hit save. We can head back into Unity, see that no errors are here, but it's going to tell us that pos is not used, which is very important because we have to put pos in there. Great. So now we should see it working, and we can click on our spawner, and we can drag in the ball and set the amount. Just leave that to 100 for now. Now when we hit play, we should see that we spawn into the scene, and right about now, it spawns a huge amount of balls. And then they're just going to stand there and jump. And if I walk into these, they're going to start falling at a pretty rapid rate. So we have this huge amount of balls falling down. And the recording might not show this, but actually we have a pretty good frame rate throughout this demonstration. I'm just going to put on the stats here so you can see our frame rate. Now we spawn. Not a single frame drop here. And now all of the rigid bodies start moving and the FPS is completely steady. So that's really amazing, both on behalf of the physics system, but also when it comes to the spawning operator. I will, however, show you that it does do some calculation, because this case right here is an excellent example of how we can use the profiler. Because if we can't see a visual change on the FPS, or if we can but we don't know what's causing it, we can use the Unity profiler to tell us what is currently taking up a lot of performance use, both on the CPU, the GPU, memory-wise, on the physics system. Everything is there, and it's really amazing, and it's now available because all of the pro features are now free. So if we go under Window and select the profiler or Control 7 and simply dock it here. Actually, I'm going to dock it down here by the console and then just drag it up so we can see both the game view and the profiler at the same time. You can see we have a bunch of different things here. Right now it's excluding the GPU, but we can just include that if you want to. So it's right here, but I'm simply not going to include it because it's not really that important for the test we're doing here. And I'm going to check on everything, physics, vsync, GI, others, every parameter there is. I want to see it here and make sure it's set to record. Now we can hit play and we can see in real time what is happening. And as soon as they spawn, we should see a spike. Cool. So the first spike we see is right here, but you can see there are multiple spikes in here, and some of them are caused by rendering, some of them are caused by physics, and it also has this very annoying vsync, which doesn't really tell us a whole lot. It spends quite a lot of time on it, but vertical syncing is something that you can choose to have or not to have, and not really something that is easy to optimize. So we can disable that. This makes everything quite a bit easier. If we are not focusing on the rendering, which we are not right now, we can disable that too. And also, stuff like the garbage collector, global illumination, and others is not important to us right now. It's really only the physics system and scripts. And the physics systems you can see down here. So we're going to disable the physics system on the CPU also. But just notice before we do how small of a change there is from this point where it's only our character controller to over here where we have actually 100 rigid bodies acting at the same time. It's really amazing. So now let's disable that. And we can see now only the scripts, how much they take up. And you might be wondering, well, why are there even any, why is there even happening anything up until this point? I mean, we are not running any scripts. But yeah, some scripts are of course included with the first person controller, so that's what you're seeing. But if we go over here to the first spike, right about there, we can see this, that wait for target FPS takes us 61%. Please just ignore that. But if we select our behavior update, this is where we see all of our mono behaviors updating. So if we go under this, we can see spawner.update. That's our spawner's update function. And inside of this, we should see an instantiate call. And we can see that it has 100 calls. How much time it takes 6 milliseconds, which is amazing considering how many we are spawning. And the percentage of time it's taking up on the CPU that frame. So that's really amazing. And we can even go further in and see what the instantiate function is actually doing. So this profile is completely amazing on isolating issues, finding out what is taking time, really comparing like on an actual use case, on an actual use level, what method is best for doing what and all that. Because you can theorize about performance all you want, this actually shows you a graph. So that's really, really awesome. And you can hook it up to an external build and do all kinds of stuff with that. So that's a feature that is very handy to have in Unity 3 now. So I'm going to clear that out, and that will pretty much conclude the that will conclude the profiler part, but I still have to talk about the most important API change to scripting, which is removing component property getters. Aha. So what does that mean? That basically means that you are going to see quite a bit of get component when scripting. So let's try out a use case here. So let's say that we want our balls to spawn, but we also want to tell the balls that that the rigid body should disable gravity. We want some no gravity balls. That sounded wrong. But what we are going to do here is we are going to go into our scene. We're going to drag down our spawner here, so we are able to interact with these so-called low gravity balls here. So then we're gonna head back into Unity, and what we can do is, of course, we can collect the rigid body and then access one of its properties called gravity and set that to false. So in order to do this, first off, we want to collect our instantiated prefab. And we do this by making a temporary variable. So let's, for example, say game object. And then we're going to call this just go for game object equals instantiate. And we are going to have to tell it that it should instantiate as a game object. So you make sure to cast it. And then here we can say that go dot rigid body. And no, why is this not working? I mean, if we say go dot transform, it's here. If we say go dot game object, it's here. But if we say go dot rigid body, it's not. And it's not with collider either. Or audio. Why is this? Well, that's because Unity has made a choice to go in and remove some of the easy accessors that they've made. They've made these quick component getters, so we don't have to do get component each time. But they found out that this actually confuses more than it gives. And it also doesn't very clearly show how much performance it actually takes up. It looks like we are not doing a get component call, but really we are. So that functionality has now been removed to make everything more explicit in our code. I really like the decision. Some newer members often don't because they now have to write more code. But really it helps you look at or understand what the code is doing. So we have to do go.get component, then find the rigid body component. Oh, get component rigid body like this. And then we can do dot gravity, use gravity equals false. This is now the new way to access the rigid body. And it's the same with the audio, it's the same with collider, it's the same with all kinds of components. So that's very important that you understand that now. So let's save that and let's head back into Unity. And let's hit play here. And we should say that a bunch of balls spawn. Whoops. Apparently we're getting a null reference exception and this is going all kinds of crazy. It's not set to an instance of an object. I'm sure we are spawning, but for some reason it might not be finding the rigid body on the component, but it should be. I'm just going to quickly look into this and find out what I'm doing wrong. Okay, so I've found the solution and simply go ahead and replace game object with transform both here and it will work. So now you see when we hit play, wait a second here for it to spawn. There we go, there they are, and they are now without gravity. As you can see, they are floating off into space. So that's basically it for the scripting part of this tutorial. Hello everyone and welcome to the last section of this Unity 5 primer. In this part we are going to have a look at the new ability to export to WebGL. What this does, it allows us to use Unity or run Unity games in the browser without downloading a plugin. So it's much more smooth in the sense that your users don't have to install some kind of ugly plugin and then might miss out on your game. So if we just open up Unity here, and this is going to be a quick walkthrough, we can go to File, Build Settings, so press Ctrl-Shift-B to open up the build settings. And I just have a small game here, which I'm actually just going to show you here. We made that right before in the scripting section. And you can see it just spawns some balls, and then you can go into them, and there are 100 physics objects acting together here. I'm just going to show you how quick that runs in the browser. I'm also just going to bump up the sensitivity of the FPS controller because for some reason that goes down when you are exporting to WebGL. So I'm just going to find the first person controller here, go into mouse look and change the X and Y sensitivity to something like 6 instead. Just try this out in game. That's much nicer. Cool. So what we can go ahead and do now, whoops, just stop playing there, is go to the build settings, so Ctrl-Shift-B. We can add the current scene, make sure that you have a scene added there. Make sure that you go down and select WebGL, and it's currently only in the preview version. It will have quite a few bugs, so be aware of that. And actually, the first time I tried to build, I ran into one. Currently, with this configuration and this scene, it won't build for me if I select slow, which means that it will build fast. So instead, as the optimization level, I had to select fast. You can play around with that, and really, it takes some time to export as is. You can also check if you want a development build. I'm also going to leave that off because I had some trouble with that too. But again, this is a preview. So once you're happy with that and have went into your player settings and maybe typed in your company name and the product name, which is going to be Awesome Physics Red Balls All Over of Destiny, of course, and put in an icon and all that. Then we are ready to hit build, and once you do that, you can maybe make a builds folder, which I've already done, and I've already built it because it takes, again, quite some time. So once you've done that, you can head into the folder, go under Unity 5 Primer, Builds, and you can see that there are a bunch of folders here. We have the compressed data, we have the release, also some data files, and then the template data. And the template here is really just the style of the web page. If we open this up with Notepad++ here, just gonna remove the other things I've been doing here. You can see that you can adjust the CSS file here. This is simple, pretty standard CSS. So you can adjust how you want your page to look, and you also have some different images. And then we of course have the index page itself, which is you can of course also edit. This is just normal HTML with some JavaScript in it, and yeah, so that's what you have the ability to kind of edit. If we right click on this, you're going to have to select open with Firefox. And the reason why is Firefox is actually the only browser currently that is supported. If you want to run this in Chrome, which I assume, or at least hope that most of you want, then you're going to have to download Chrome 35, which is currently in beta. And the reason why it doesn't work with 34 is because it sometimes freezes because there's an issue with Java. So if that's a problem, if you don't want to get the beta, just download Firefox. It's a very quick install. I've done that, so that works quite fine. So as you can see, it just opens up. We have this cool interface here. You can play around in your scene here. You can see the balls jumping up and down, and you can maybe even make this full screen. You can see just how slowly it is to move the camera here. So again, you might want to rebuild that. And then we can just walk into these, and you can see all of the objects falling down at actually a very nice frame rate. So it's having no trouble handling over or just about 100 physical objects. So that's a really great performance. So I just wanted to quickly show you how that actually works, and that it actually does work, somewhat at least. So yeah, that was just the WebGL part of this video. And that pretty much concludes the whole Unity 5 Primer video. I hope you really enjoyed it, that it lived up to expectations. I've spent quite a lot of time. It's really a long one. So if you've made it all the way through, congratulations, you are a champ. Really, really well done. And it would of course mean a lot if you can share this video to other Unity users that you might know, so they can also get a hang of Unity 5. I've really put some work into this video. So I hope you enjoyed it, and I'll see you in the next one.